Reverse Polish notation is a mathematical notation in which every operator follows all of its operands, in contrast to Polish notation, which puts the operator in the prefix position. It is also known as postfix notation and is parenthesis-free as long as operator arities are fixed. The description Polish refers to the nationality of logician Jan Łukasiewicz, who invented Polish notation in the 1920s. The reverse Polish scheme was proposed in 1954 by Burks, Warren, and Wright and was independently reinvented by Bauer and E. Dijkstra in the early 1960s to reduce computer memory access and utilize the stack to evaluate expressions. The algorithms and notation for this scheme were extended by Australian philosopher and computer scientist Charles Hamblin in the mid-1950s. During the 1970s and 1980s, RPN was known to many calculator users, as it was used in some handheld calculators of the time designed for advanced users, for example, the HP 10C series and Sinclair scientific calculators. In computer science, postfix notation is often used in stack-based and concatenative programming languages. It is also common in data flow and pipeline-based systems, including Unix pipelines. Most of what follows is about binary operators. A unary operator for which the reverse Polish notation is the general convention is the factorial. Explanation: in reverse Polish notation the operators follow their operands. For instance, to add 3 and 4, one would write 3 4 plus rather than 3 plus 4. If there are multiple operations, the operator is given immediately after its second operand. So the expression written 3 or 4 plus 5 in conventional notation would be written 3 4 or 5 plus in OPN, 4 is first subtracted from 3, then 5 added to it. An advantage of OPN is that it obviates the need for parentheses that are required by Infix. While 3 or 4 or 5 can also be written 3 that means something quite different from 3 or 4 5. In postfix, the former could be written 3 4 5 a, which unambiguously means 3 which reduces to 320 The latter could be written 3 4 or 5 which unambiguously means 3 4 or 5 Despite the name, reverse Polish notation is not exactly the reverse of Polish notation, for the operands of non-commutative operations are still written in the conventional order. Practical implications: in comparison testing of reverse Polish notation with algebraic notation, reverse Polish has been found to lead to faster calculations, for two reasons. Because reverse Polish calculators do not need expressions to be parenthesized, fewer operations need to be entered to perform typical calculations. Additionally, users of reverse Polish calculators made fewer mistakes than for other types of calculator. Later research clarified that the increased speed from reverse Polish notation may be attributed to the smaller number of keystrokes needed to enter this notation, rather than to a smaller cognitive load on its users. However, anecdotal evidence suggests that reverse Polish notation is more difficult for users to learn than algebraic notation. Postfix algorithm: the algorithm for evaluating any postfix expression is fairly straightforward. While there are input tokens left, read the next token from input. If the token is a value, push it onto the stack. Otherwise, the token is an operator. It is known a priori that the operator takes n arguments. If there are fewer than n values on the stack, error, the user has not input sufficient values in the expression. Else, pop the top n values from the stack. Evaluate the operator, with the values as arguments. Push the returned results, if any, back onto the stack. If there is only one value in the stack, that value is the result of the calculation. Otherwise, there are more values in the stack, error, the user input has too many values. Example, the infix expression 5 plus 4, 3 can be written down like this in OPN, 5 1 2 plus 4 plus 3 The expression is evaluated left to right, with the inputs interpreted as shown in the following table. When a computation is finished, its result remains as the top value in the stack. In this case, 14. The above example could be rewritten by following the chain calculation method described by HP for their series of OPN calculators. As was demonstrated in the algebraic mode, It is usually easier in working a problem like this to begin with the arithmetic operations inside the parentheses first. 1 2 plus 4 a, 5 plus 3 a, converting from infix notation. Dijkstra invented the shunting yard algorithm to convert infix expressions to postfix, so named because its operation resembles that of a railroad shunting yard. There are other ways of producing postfix expressions from infix notation. Most operator precedence parsers can be modified to produce postfix expressions. In particular, once an abstract syntax tree has been constructed, the corresponding postfix expression is given by a simple post-order traversal of that tree. Implementations. History of implementations. The first computers to implement architectures enabling a PN were the English Electric Company's KDF-9 machine, which was announced in 1960 and delivered in 1963, and the American Burroughs B5000, announced in 1961 and also delivered in 1963. One of the designers of the B5000, Robert S. Barton, later wrote that he developed a PN independently of Hamblin sometime in 1958 while reading a textbook by Copy on symbolic logic and before he was aware of Hamblin's work. Frieden introduced a PN to the desktop calculator market with the EC130 in June 1963. Hewlett-Packard. Hewlett-Packard engineers designed the 9100A desktop calculator in 1968 with a PN. This calculator popularized a PN among the scientific and engineering communities, even though early advertisements for the 9100A failed to mention a PN. The HP 35, the world's first handheld scientific calculator, used a PN in 1972. HP used a PN on every handheld calculator it sold, whether scientific, financial, or programmable, until it introduced the HP-10 adding machine calculator in 1977. By this time HP was the leading manufacturer of calculators for professionals, including engineers and accountants. HP introduced an LCD-based line of calculators in the early 1980s that used a PN, such as the HP-10C, HP-11C, HP-15C, HP-16C, and the famous financial calculator, the HP-12C. When Hewlett-Packard introduced a later business calculator, the HP-19B, without a PN, feedback from financiers and others used to the 12C compelled them to release the HP-19BII, which gave users the option of using algebraic notation or RPN. From 1990 to 2003 Horsepower manufactured the HP-48 series of graphing RPN calculators and in 2006 introduced the HP-50G with a 131x80 LCD and a 75 MHz ARM CPU that emulates the Saturn CPU of the HP-48 series. As of 2011, Hewlett-Packard is producing the calculator models 12C, 12C Platinum, 17BII, 20B, 30B, 33S, 35S, 48GII and 50G which support a PN. Princetronic, Prines and Princetronic were own brand trade names of the British Dixon's photographic and electronic goods stores retail chain, which was later rebranded as Currys Digital Stores, and became part of DSG International. A variety of calculator models was sold in the 1970s under the Princetronic brand, all made for them by other companies. Among these was the Programmable Scientific Calculator which featured RPN. Soviet Union, Soviet programmable calculators used a PN for both automatic mode and programming. Modern Russian calculators MK161 and MK152, designed and manufactured in Novosibirsk since 2007 and offered by Semico, are backward compatible with them. Their extended architecture is also based on reverse Polish notation. Current implementations. Existing implementations using reverse Polish notation include any stack-oriented programming language, such as Forth, Factor, PostScript page description language, Bifunge, Joy. Hardware calculators, some Hewlett-Packard science engineering and business finance calculators, Semigo calculators. Software calculators, Mac OS X calculator, several Apple iPhone applications for example reverse Polish notation calculator, several Android applications for example Real CALC, Unix System Calculator Program DC, Emacs Lisp Library Package Calc, Xorg Calculator, GRPN Scientific Engineering Calculator using the GIMP Toolkit, F-correlatives in multi-value dictionary items, Retool, a widely used tabulating and graphing software, Math, a program for algebraic operations on netCDF grids, part of generic mapping tools suite. See also, references. External links, RPN or DAL. A brief analysis of reverse Polish notation against direct algebraic logica by James Reddin, RPN at HP Museum, postfix notation mini lecturia by Bob Brown, 5th, An Alien Conlang with ALIFO Grammar by Jeffrey Henning, Good Ideas, Through the Looking Glass by Niklaus Wirth, Ambi-browser-based extensible RPN calculator by David Pratton. Online RPN calculator provides a visualization of stack as typed. RPN example in VB.net. A VB.net example code with Evil method based upon RPN notation by Xavier Juncker. Copyright